Hello, my name is Janet. I am part of Link3D, and we're really excited to launch this event today for the America Makes Virtual Game Day series. Hey, Erica, thanks for joining us. We want to now bring on John Wilsinski. While he comes on board, Link3D is the digital sponsor for this event. We are an additive workflow software company, and we're really excited to partner with us to help connect not only the digital thread, but the digital community. Hey, John, how are you doing?
I am wonderful. How are you, Janet?
Wonderful, wonderful. I hear you have a lot of interesting and exciting things to share with us today, so I will leave the floor to you.
We've got a couple, so we'll start with those. So you can see on the screen right now. Well, first of all, thank you all for joining. Really excited to continue this game day series. Here we're focusing on a variety of different topics. We've hit everything from supply chain to where is additive manufacturing going, but we're really excited to be bringing this AM intersection with athletics topic. So it's something that it's relatively new for us. We've hit on individual speakers here and there over the years, but this will be the first time we've really focused on it. So really excited to see what the speakers have to say. Therefore, I won't take too much time getting this thing started, but I did want to make everyone aware, so we're trying to continue to bring content to the community in a variety of different formats. So many of you at this point are familiar with our game day series. We're going to continue doing those. It's somewhere where we're trying to get topics out to the community that maybe don't fall directly in the swim lane of one of our technical reviews or into MMX or something like that. So our plan is to continue doing that over calendar year 21. And we're excited to be announcing this mini TRX, as we're calling it. It will be on December 10th. It is going to be picking up and continuing the conversation around standards, and it will, as I said, take place December 10th. Registration is actually open. I just see Tara just posted the link. So encourage you to go out and register for that. It's about a day of content. There's a variety of different speakers. There's going to be updates from some of the different standards bodies, as well as a number of different technical talks, including some project out briefs. There's a couple of programs that are closing out at the Institute, so we'll be having them and giving them the opportunity to close out their programs in front of the community. So at this point, I'd like to thank everyone for coming on today. I would like to bring our moderator to the stage, if we could, and we'll get this started. Eric, you just should have to click on your camera.
Hey, how's it going, John?
There he is.
Can you hear me?
There you are, sir. Yep, we can hear you well. So we'll hand it over to you, sir, and you can bring the panelists to the stage and get us started. I would one quick thing, just so everyone remembers, especially if you haven't participated in one of these game days, it really, it thrives off of interaction. So we want you to, and really encourage you to ask questions. There is a Q&A button if you look on the right-hand side of your screen in that pane. If you click on Q&A, you can pose questions there. We also encourage you to vote questions up, and we'll try to make sure we're addressing those questions that get voted up by the community. There's also a chat function where you can find other folks who are here. So there's quite a variety of people who've called in today and will over the course of the next couple of hours. So if you're looking for somebody, you can direct message them through the system there. But really encourage you to ask questions and get involved. So over to you, sir.
Well, John, just one quick question. When I do need to bring the others onto the stage, do I do that, or is that automatic?
It'll be done automatic. They'll be jumping on here in a second.
Awesome.
Thanks.
Okay, so I'm really excited about the panel session today, which I am sure is going to be thought-provoking and potentially entertaining. And we really have a star-studded panel of experts that live at that intersection of additive manufacturing and athletic gear. And really, in my mind, in the context of gear, the benefits of additive manufacturing are really twofold. And I'd like to talk about that today with the panel. But first, you've got mass customization, which allows for gear to conform to specific anatomy, like the head, the foot. But also, second, the big benefit is complex geometries, with spatially varying lattices that allow for the tailoring of, the dynamic, mechanical, response of a system to improve energy absorption, deflection. So I'm just really pumped to be here. And I think this is going to be a really interesting conversation. And so at this point, I want to go ahead and ask that the panel be added. And I'll go ahead and introduce the panel and ask each of the panelists to provide their background and involvement in additive manufacturing. Let's see. So I guess I'll wait until they come on board. All right, here we go. And I see Erica. So first on deck is Erica Berg, who works at Carbon in a company printing football helmets that have actually seen action on Sundays. And I saw Erica's keynote presentation at Rapid, maybe in 2019. I'm not sure, maybe in 2018.
Yeah.
When she described Carbon's collaboration with Rydell. So Erica, please tell us about your involvement in additive manufacturing.
Yeah, thanks, Eric. My name is Erica Berg, and I lead the business development team at Carbon. So I've been there for a number of years. And as Eric mentioned, I led the Rydell program from first engagement through to launch. So very exciting program. My background is in engineering and consulting. And so it was a perfect mesh of partnering with a customer to help them understand how to incorporate additives into their products, even though they decided to not get a printer and use the printer themselves. They partnered with us to say, how do we bring improved products to market? And that was such an incredible exercise. And from there, I have grown a team to look at an entire portfolio, primarily focused in elite athletics, but we're looking at across products. And love my job at Carbon. Would love to connect with anyone in the audience who is interested in potentially bringing DLS into their products and their applications.
Awesome. Yeah. So one quick comment would be that you're talking about elite athletes. At some point, I need to get a common Joe like me needs to get some cool gear for sure. But
absolutely.
So next, right?
Yeah, we're working on that. We want to drive innovation to as many people as we can. Absolutely. So we're starting with the premium products, and we're absolutely building out. And I think even Thierry will talk about how we're doing that with CCM.
Awesome. So Thierry Patel is the next one I'll introduce. He's from CCM Hockey, a Canadian company that's well over 100 years old in the production of hockey equipment. So Thierry, if you want to give us a little background on yourself.
Yeah. Hi, everyone. I'm really happy to be here. It's really exciting and interesting to see all of you. So I'm the Advanced Design Manager at CCM. My role is to translate the user and science data into products. So I'm an industrial designer. That's my background, and I'm doing sports products from the last 15 years. So I've been into that industry for a long time. I'm really an advocate of user-centric design, and that's what I fight for on a day-to-day basis, and that's basically what led me to additive manufacturing, because the properties of additive manufacturing, as you said earlier, Eric, are really linked to the user, like the geometries we can do, also the customization we can do with it. It's that's why I was really interested into that technology. I've been working with Carbon a lot, and we have a really interesting collaboration together. So yeah, that's about it.
Well, I'm excited to hear about the project, and we have a little video, I think, in a couple of minutes. And of course, Jim Sauerbaum, you're also with Carbon, and you were involved with CCM. So I'm really pumped to hear about what you guys are doing. But Jim, yeah, tell us about your background.
Yeah, great to be here and get to meet everybody that's participating today. My background is a little bit unique. I haven't been in engineering or manufacturing. I actually came from healthcare. So I was in healthcare for about 10 years, really on the technology side, whether it was implementing new systems in health systems or partnering to integrate systems together to then bring to a new health system, which was a big world for me for about 10 years. And then about 2 years ago, I joined Carbon and continued on that B2B phase to actually find out what is the problem that a lot of brands are facing in their product development and their manufacturing, and start to help them realize what's possible using DLS and 3D printing. So I've had the pleasure of working with CCM kind of from really when I first started at Carbon, as well as many other brands that are working on some really kind of unique things behind the scenes that we really can't wait to share once we're able to. Awesome.
And then, yeah, so I'm so excited to hear about what you guys are doing. And then finally, I'd like to introduce Dr. Jeff Crandall, who is at BioCore LLC. He's a professor at the University of Virginia, and he serves as a consultant for the National Football League. Dr. Crandall wants to present some slides to give some of the details relating to athletic head injury and how additive manufacturing can make a difference. Dr. Crandall, please tell us about yourself and let us see the.
Yeah, so first I'll give you a bit of background, and then we'll see if I'm successful in sharing the slides. We've been struggling this morning, but I think as Eric said, I chair the NFL Engineering Committee. And our role there is really how do we take engineering and apply it for injury prevention strategies? And so equipment that we're going to talk a lot about today is one of the key cornerstones. But obviously, we also have to look at other avenues, education, as well as enforcement, as well as rules. So it's fairly comprehensive. We do head to toe. And I'm going to try sharing. I see Andera's got some slides up. Let me see if I can share some of mine. I may not be able to. So Andera, you're sharing?
I have two for you, Jeff.
Okay. So hopefully everyone's seeing that. So what we're showing is a slide of sort of the injury prevention work we do in the NFL. If you look over on the left, you see we've got a player there, and that's to remind me to tell you that literally we study injury prevention from head to toe. So everything from helmets to cleats to infrastructure like turf. If you look sort of on the on-field injury tab up there that Andera is sharing, one of their key things or cornerstones of what we do is let's understand what's happening on field. So every year we literally look at thousands of injuries that occur from head to toe. We look at tens of thousands of non-injury events because, we want to make sure that we understand when players are injured and when they aren't. One of the cornerstones, though, is not just looking at these and saying the when, what, where, how, and why, but we need to get quantitative. And so there's a big part of what we do is measuring what happens on field. So we show up there, we've developed some MEMS sensor technology that goes in mouth guards that tells us head kinematics. The NFL has player tracking data, both in practice as well as games. So we know accelerations of the body, we know velocities, we know distances. And then a lot of what we've been working on is we sort of take a data analytics approach now and machine learning, and we do a ton of computer vision. So we look at things like pose estimation, we track helmets, we track shoes, we say what angle was that knee bent at from video, and we do that automatically. That's one of the big things that we've gone to is doing it at scale so we can track each and every player on each and every play. Then I think more of interest to this community is how do we take that information and how do we share that with designers and innovators? And so what we've done is take that quantitative information and said, let's reduce the very complex on-field environment to a laboratory setting. Let's give the people a test that they can design to. And so there's an example there of we developed a pneumatic impactor within the NFL that's now become an industry standard that allows us to replicate the sort of head motions that occur. On the lower right there is a turf tester. So we can actually push a cleat in at the right orientations, the right forces, and twist it within the turf, and then we can say, hey, which turf appears safer? Which cleats are safer? And then I think on the tools there is we recognize that I think that up until, say, the last few years, a lot of sports equipment had not been sort of state of the art, commensurate with, auto safety or aviation or aerospace. And so we said, what tools can we provide to these entrepreneurs that are trying to design to that test methodology? So we reversed engineered helmets. We linked them with all the state-of-the-art biomechanical models. So we can tell you, if you've got a helmet design, not only can we tell you the head acceleration, we can tell you what the brain strain is. We can tell you what the probability of injury is. And so you can incorporate that. And so we've gone with a computational framework now for helmets. Shoulder pads are shown there, as well as footwear and turf. And I've got just one more brief slide that sort of ties in more for the discussion today. If you can go to the next one on, Dara. Maybe. The next one that I wanted to tell you about, there it is. And the way that ties into this community is we recognize that there's been significant progress in the last few years on helmet design, and some of that you're going to hear about today. But we want sort of the next generation. We want 15, 20, 25, 30% improvement from where we are right now. Sort of what I would call revolutionary progress, not evolutionary. And so we've got a helmet challenge. It's a $3 million challenge. Prototypes are due next June. And I think we knew there were opportunities for additive manufacturing in this. So we did a kickoff meeting in Youngstown last year with America Makes. And the idea is develop a prototype that uses these tools, uses these tests, and it significantly advances safety. And on the bottom here, I've got one final parting thing, which is we looked for folks that had that were starting out that needed seed money to get ready for this helmet challenge. And we had 100 submissions. We chose 4. And the important thing to show here is that all of those 4 used additive manufacturing. They all used a computational framework. They all used collaboration, universities, large chemical companies, additive manufacturing. And that's exactly what we think is needed. So there's a brief overview for you, Eric, and I'll let you get back to the rest of this.
That's fascinating. That's just so exciting. So, okay, so the next thing I want to do before we really start the panel discussion was we were going to show a quick video that will talk about the CCM helmet. So on Dara. Awesome. That was extremely cool. So Yeah, before we start the panel, I just want to quickly make some announcements and guidelines for the audience. If you have questions or comments for the panel session, use the chat feature or the Q&A feature to communicate with us. And if you don't have comments, of course, you can still influence the voting questions. And the panel has asked that we start with posing 3 questions to the audience to consider and ruminate on during the panel session. And we ask that the audience provide that feedback through the chat feature. And as comments arrive, we'll integrate that into the conversation. And the 3 questions that were being asked of the audience are, what are the biggest concepts you and the audience see as required to improve products in athletics that the additive manufacturing industry may not be currently considering, number 1. Number 2, to further the next generation of energy management products in the context of impact, what data needs to be captured and analyzed that hasn't been considered yet and should be? And then finally, mass customization, personalization of products is a major benefit for companies starting to leverage additive manufacturing. However, additive can be maybe a daunting process to integrate into manufacturing and design workflows. So the third and final question is, how can the additive manufacturing industry help enable the personalization in your brands and products? And so think about those, and we can, bring those in from the chat as we go. So now I'd like to start with the discussion, and I'd like to throw out the first question, and we'll take questions from the audience and have the panelists discuss this. But the first thing I'd like to ask is, well, beyond the helmets and shoes that we know about, and which have been the primary focus, are there other application opportunities for protecting the health, 1, and 2, improving the performance of athletes? And what does the panel believe is like the next killer application? And I guess we could, we ended with Jeff, so maybe we could start with Jeff on questions, and we'll just go round robin.
I think it's a good question, Eric. And one thing I would say is you listed sort of helmets and footwear as areas that are already being addressed. And what I would say is that cleated footwear, which obviously a number of sports utilize, has not really been addressed. You saw Nike sort of dabble around 2014 in 3D printed cleated footwear. But I think there's huge opportunities. If you look at the NFL, the number one concern of players, our number one burden, our number one frequency is lower extremity. And if you look at footwear, it really is not where it needs to be in terms of cleated footwear. It's the number one complaint of players. Their feet roll off, they don't fit well. And to give you a little bit of a history lesson here that I thought of is, we measure shoes actually in sizes based on barley corns from the 14th century. And so if you want to talk about an opportunity for customization, modernization, I would put footwear still up there. But of course, body pads, shoulder pads, bracing, all kinds of countermeasures. But I think for us, I would advocate for still sticking with footwear because I think there's opportunities.
Awesome. Well, then let me, I think, Jim, you were next in line then. Do you have some insights or comments?
Yeah, I think really when we're thinking about elastomeric lattices, we're really thinking about how does that manage energy in a way that foam is kind of being replaced in. So when we're starting to have these conversations with these brands that are looking to get into additive, it goes right to the foam properties that they're limited by and where those foam applications are being used on the body. So I think padding in general, whether that's head to toe padding, is going to be a real explosion in this area from both an improved performance standpoint, but furthering down that customization path. So I think we're really just kind of at the tip of the iceberg or the top of the human at this point for doing that. And there's so much more space for us to travel into.
Awesome. That's really cool. And Terry, you want to add to that possibly from the hockey standpoint?
Yeah, well, I don't want to talk too much about that. There's a lot of interesting stuff happening for sure on our side, but there's on our side there's still a lot of interesting thing to improve in the helmet field. I think there's head injury is a big thing. It's a big problem in sport right now. Not only in football, it's the same in hockey. So there's still a lot of work to do, and we're putting a lot of efforts and design intention into that field. And the helmet we launched lately is a great success, and we want to build on that foundation for sure.
Cool. And Erica, how about you?
Yeah, I'm gonna build.
Oh, you're muted. I think you're.
Can you guys hear me now?
I can hear you.
Okay, I can hear you now. Sorry.
Okay.
It was a delay. Sorry.
No worries. I will build on what a number of the other panelists said. I think, in the last decade or so, we've really moved to certain expectations of on demand. You order something and you expect to get it within 2 days. And I really see that next frontier to be on demand, quick, but also for you and custom. So I think that's really what we're going to push. And I'm so excited to be partnering with companies that are helping us push those boundaries. And as you were mentioning earlier, Eric, an average Joe wants to get a custom helmet. People want custom products and they want it their way. It's not just immediate, it's immediately for me. And I really am excited to be helping chauffeur that along.
That's awesome. So yeah, the average Joe, not an elite athlete. I can't wait.
Right.
Well, great. Those are great answers. So a second question, and then maybe we'll start looking for the audience if they want to add some. So one thing that strikes me is that commercially available 3D printed shoes, right, are really a testament to the durability of these next generation materials that are in 3D printing, particular the elastomers. Is there any insights about, breakthroughs that are imminent that could further enhance athletic gear, maybe in the outer shell or better elastomers? Is there anything you guys would want to mention there? And I guess we'll go in the same order. Dr. Crandall, if you could tell us what you're thinking.
Yeah, well, I hope so. I'm sort of the end user here, and I hope they've got things in the work stream. What I would say is, we do a lot of optimization work where we just look at, given an available space, what could be achieved for energy management. And I think I realize it's a combination of structures and materials, but based on what we've done analytically, based on what we do computationally, we see lots of opportunities for improvement. I think the other thing I'd like to challenge them to is we see a lot of work on improving upon materials and current design concepts. I'd like to challenge them and the manufacturers and say, think outside the box, because I don't think we're in an evolutionary design point where the current helmet has to look that way. I think with new materials, new structures, we're replacing components, improving them drastically. But I think, again, computationally, we see opportunities where the helmet with 3D printing doesn't necessarily look like the helmet that we've got today. So
that's fascinating. But it still needs to. If we do change the form and make the helmet super big, I think the mirror test has to be there.
Absolutely.
Yeah, Jim, what do you think?
I think it's a great point, and I remember early on hearing our co-founder Phil talk about some of the different durability tests that materials were going through, and one of the points was these midsoles, they can last forever in some cases. How do we make sure that the materials are designed to what they actually do in addition to durability? So from our standpoint, part of it is also looking at tuning those materials to be more specific to the profile that you're looking to achieve out of it, whether they're energy damping or energy return in their bulk properties. Learn from that cycle and then figure out what the customer values most out of it and continue to refine that formula to get a better performing, better energy damping material that maybe next version is lighter weight. Maybe next version is offering different colors is something that we hear about quite often. But I think beyond kind of the space that we're currently kind of showcasing products is where we want to see materials go is kind of elevate us to that very next level of competition. You start to think about some of the sports that really focus on body protection and head protection that are beyond me hitting my head against the lineman 60 times a game me driving a car as fast as I can and trying not to hit a wall. How do you make material breakthroughs that can compete with the World War II foams that do a really great job of what they do at a great price point and lightweight? How do we incorporate those aspects of a product into something that is highly engineered, both from a structural standpoint, but also a material standpoint? And that's where I'm really excited to see the materials kind of roadmap and development go as additive pushes further into athletics.
That's fascinating. Yeah, the color, that's a good point. I didn't think about that, but that goes back to Jeff's mirror test, right? You might feel like you look better in black versus. So Terry, what do you have on the hockey perspective?
Well, it's the same. The mirror test is a Patel, and it's to be honest with you, there's a lot of element molds in somewhere in the ocean because they failed the mirror tests, right? There's it's so important, and that's where like that's probably the most obvious intervention of the team of designers, right? We have to make these things accepted, but meanwhile we have to make them innovative, and we have to make them look more advanced in a way. So for sure, as Dr. Crandall said, it has to show these technology can give us new opportunities, and we have to build on that. It's a very, very, very tough challenge, but that's something we work on a daily basis.
Definitely. Erica, what's your take?
Well, I think we're certainly always looking at advancements in materials and what can we do to constantly innovate and improve and evolve in the great materials that we already have. What I think is very interesting and unique to our technology at Carbon is the way that we incorporate software to be able to change the response of the materials and really control the energy. And so we can take something that's one material and open up an entire spectrum of responses and feel based on the software and the way that we design that material to respond. So I'm really excited to see how we push software innovation to change the designs of and almost make smart materials, right? Because you have a material that is designed to respond closer to your head or closer to your body to feel comfortable and soft, but then provide that impact resistance and energy dissipation that you want when you go through an impact or something happens, but also be able to have that resiliency in the way that it's designed so it pops back and maintains that form to keep a structure that you want. So I think the software is something that is equally as important as what the material is how is it designed and how are you using data to really drive that innovation.
Yeah, so kind of at a macro level, you're changing the material by changing a lattice and so forth.
Exactly.
That's just so cool. Okay, so yeah, this is absolutely fascinating. So next question would be maybe related to that. If 3D printing enables new complex geometries to tailor the mechanical response, can you comment on any breakthroughs, maybe in design or geometry, that can further improve athletic gear? And I think, Erica, you just kind of answered that question, but is there specific breakthroughs, or can you comment on anything that we should be looking for in the next 6 months, 12 months?
Yeah, well, we recently made available our design engine. And so this is where our customers can come in and design their own lattice structures using the tools that my team gets to use internally at Carbon. And so those breakthroughs in software, I think, are really what are going to push further innovations with the existing product suites that we have. So I'm excited to see that software continue to evolve and meet the needs of our customers. That's the main thing that I'd like to bring up right now. Yeah.
So as a professor, the first thing I've got to ask, is there like a university discount to get this software? Or okay, yeah.
Yeah, we'll figure something out, Eric. We'll figure something out.
All right, I'll go to Jeff then. What do you think about the idea of design, geometry? Is there anything that you see?
One of the challenges we see is, many parts of the body are deformable, and we see that there's surface geometries. And so I think, there's a lot of interface characteristics. I know hair has been a challenge, for example, where 30% of our players have hair that, exceeded, I don't remember whether it was a half-inch standoff or what it was, but it makes challenges. And I think as we migrate to other parts of the body, foot scans, for example, if you had a Brannock measure your foot, you get something different than a foot scan. Or we're scanning for body padding, and there's working on 3D printed, but how do you address that human interface? So there's a complexity there about the interface, and it changes with mobility and motion. It changes. So I think one of the challenges I would like to see is how we incorporate sort of the biomechanics, the anthropometry of the body in a dynamic sense into the design process.
Yeah, so that's fascinating too. It's just the organic nature of the human body, obviously, with hair and the ability to be flexible. That makes a challenge from the standpoint as an engineering professor. I like to think of geometry as sort of static, but that's just not appropriate, I guess. So yeah, very good. Jim, I know you're working with the Carbon software, so you probably have some innovative insights.
Yeah, I mean, I think Erica kind of hit the nail on the head from the Carbon perspective of the design engine. But I mean, really, when I think about it, it's getting that design engine out into the hands of these customers, because we go through these development cycles and you've got so many different parameters that you can change in the structure with a certain amount of resources to go ahead and do that, marching up to a launch date. The more users getting their hands on this, just the more iterations that tool we believe is going to output. And we're just going to learn so much more about those mechanical responses outside of simulation and into real world.
Yeah.
So I think that's a big thing that we'll start to see customers kind of realize using that software. And then I think the other thing too is just we're always learning more and more about lattice. And a lot of what you see is what we refer to as strut-based lattices. And you've got your strut diameters, your cell sizes, your cell shapes as kind of like your general parameters to pool with. But as we kind of study lattice even further, we're learning more about surface lattices, which tend to be studied in science as higher strength to weight ratios. And how do you start to incorporate those into padding? And that's kind of another frontier that we're really starting to understand and hoping to push forward to bring these products to our customers. So I think getting that design engine out is key, but we'll be continuing to study kind of the newest things that the PhDs are working on in the universities to help us understand how does nature deal with energy, and how do we incorporate that into the tools that our customers can use. Yeah,
that's okay. So one takeaway for me is that maybe the software for generating these designs is pretty powerful, but we haven't just explored it enough, the software that exists, and you need more people, broader adoption, more iterations to explore a wider space of geometry. I think that's really cool.
Exactly.
Oh, you're muted?
Yeah, sorry.
There you go.
Again, I'm no complex geometry expert. It's not what I do. I'm not a CAD guy or mechanical engineering or a math guy at all. But I would say that I understand the complexity and the depth that lattice structures and geometries can give us. And that's why additive manufacturing is so interesting. There's no one silver bullet in this thing. It's a wide array of solutions that can be customized and personalized to everyone. So there's the question is any breakthrough in design and geometry. It's a big learning curve. We're learning a lot, and it's by doing the iterative process of prototyping and testing that we get to better solutions and improvements.
Yeah, so it's a simultaneously looking at many different aspects or benefits that 3D printing can do, geometry, materials, and so forth.
Exactly.
And then, yeah, that's very cool. Okay, so I've got another question, and this one's kind of, I guess, the most interesting to me because it's sort of near and dear to my heart. But, you know, in the general additive manufacturing research world, there's a lot of research that goes on about embedded sensors, you know, microcontrollers, intelligence, actuation, and also in related would be like advanced thermal management, which are both really hot topics in additive manufacturing. Do you guys see those general additive manufacturing concepts, research concepts that are at the vanguard? They're not, you know, in production today. But is it an inevitability that those concepts or others will be introduced into the equipment that you guys are designing and fabricating? And I guess, Dr. Crandall, can I start with you? Back to our original order.
You like starting with me. I think the answer is certainly. I think as you saw, I mean, we're continuing to embed more and more sensors. The more information we have about what the athlete experiences, whether that's mechanical loads or thermal loads, the better we can tailor equipment. And I think one of the questions that would be is, are there opportunities, Erica touched on it, but are there adaptive opportunities for either thermal management, for impact? You know, you're talking sub-milliseconds response, so I don't know exactly what you do, but and then I think one of the things you didn't mention, Eric, but would be communication. You know, for example, an alert. Do I have a blind spot? Can I put a route up there? Communication between coach and player now is an add-on to helmets. So I think electronics, even broader, tremendous opportunities to embed those in the mechanical structures. So
that's, yeah, pretty interesting. See, this might be cheating in the football, but if you were to potentially have like a vibration on different parts of the head, you might know that you're about to get tackled. You know, sort of like my car tells me when I'm about to run into my mailbox.
Exactly. That's the concept. So
very cool. Very cool. All right. I think, Jim, you're next.
Yeah, and I think that would be really kind of interesting to see come to life with the customers using this type of technology. I think from Carbon's perspective, we want to be accommodating to as much as we possibly can for our customers' requests. We're not necessarily studying that field of embedded thermal sensors or different types of sensors inside of the products, but we are studying how do we accommodate those types of things if a customer is looking for that. So I think we would certainly welcome and encourage that inclusion because it's just going to make a better process or a better product for that customer ultimately once they've got the data to understand this part of the impact and this part of the situational awareness. How do we incorporate that into the final design of the product going on the field?
Awesome. Terry, have you thought about that? I mean, this is kind of wacky academic research that I'm talking about, but it seems like it's an eventuality that it will be introduced into these products.
Well, yeah, it's a very interesting topic to be honest with you. Yeah, so when we started that helmet project with Carbon, to be honest, like thermal management was not at the top of our list. It was maybe a nice to have or an interesting thing to research. But as we were developing the helmet, I really remember that the first time we received parts and we tried it in a helmet in a hockey game. Remember that was a pre-COVID era, so we were to do things outside of our home. So when we received that helmet and we shared it and we were trying it and we realized that there's a super interesting benefit there, and that interesting benefit that could be like at some point even as important as the other properties we were looking for. So yeah, it's really you can feel it like for the user. It's a really obvious benefit. Yeah.
Interesting. Yeah. In the thermal management for sure. Erica, I don't know if you can answer this question. I understand you have to take a flight, so you might have to leave us, but.
Yes, unfortunately I do, but I did want to answer this last question. And I think what's really great about additive manufacturing is you can almost always be in eternal state of beta. And so by designing sensors into a component, again, leveraging what I was talking about earlier about almost transforming a material into a smart material, with those sensors, you can then take that data, that feedback, improve the design, ensure that you're always providing the best product and the best results to each athlete and player using whatever product based on the data that comes out of a sensor. And so we can be in this eternal state of improvement and agile iterations because the parts that we make come out final finish ready parts. You can iterate on the fly. You can really make improvements until you find something that you want to maintain and move forward with. So I think that's what's really exciting about additive. There's no tooling or long tail spooling up of a manufacturing process. You have the printer, you have the digital manufacturing system, and you can continue to iterate and evolve as you get that live data through a player usage. So I'm really excited to see how we evolve there. Wow.
Well, that's fascinating. So I hadn't even thought about the fact that the data you would be collecting could affect the next generation of products for that person.
Exactly.
Specifically. So that's awesome.
Yeah, I think that would be the dream goal, and that's what we're working towards. So
cool.
Unfortunately, I do have to excuse myself, but you're in good hands with Jim to represent my team and the company. So feel free, anyone in the audience, to look me up on LinkedIn. Thank you so much to America Makes and Eric as a moderator for this opportunity and event. It's been a pleasure.
Thank you. It was definitely awesome.
Thank you. Bye, everyone.
Bye-bye. So a couple comments so that having done research in 3D printed electronics for the last maybe almost 20 years, I'm getting old. One thing that really fascinates me about what you guys are doing specifically is if you do have an elastomeric pad, that's a really harsh environment for electronics. Maybe a sensor, a simple sensor will, that's a wire-based sensor would work. But if you're putting in microcontrollers and maybe even actuation where you might stiffen a section in like Jeff was mentioning, in a millisecond time frame, those kind of complex electronics, you're talking about some really interesting problems to solve from a reliability standpoint. But I do think that there's got to be, in the near term, I would suspect that there would be like capacitive sensors, which are just simple wires and things of that nature. And so, yeah, that's near and dear to my heart for sure. And then the other thing I think of is you can have microfluidics into these lattices where you could, and if you're playing in Phoenix in an August preseason game, you're like potentially flushing cool water to cool off the athlete. Or if you're in with, Green Bay or somewhere like, or Montreal, you might be injecting some warmth. I think 3D printing just opens up so many opportunities, and I'm real excited to be alive right now and doing research in this area for sure. So let me go to the next question then. Let me first check just to make sure that there isn't a question. Okay, there's no questions yet from the audience. So let's see. So currently additive manufacturing is being used to fabricate just sections of the shoe or the helmet, the pads maybe. I mean, what do you feel about in the future? Is it also an inevitability that the full piece of equipment would be or should be 3D printed? And Dr. Crandall, can I start with you again, or yeah. I don't want to abuse you, but
I don't think it's too far in the future. I think one of the groups that submitted for the Head Health Tech Challenge grant dollars, used an entire 3D printed helmet. So all the components, not the face mask, but the shell, the liners. And so I think from that standpoint, the future is now. I also think that we have to look as we go to more and more components. I think, one thing that's great is the degree of customization. And Eric has sort of mentioned that the move was to reduce the time of delivery. And so I think as you start to 3D print more helmets, more components, now it takes days to get a replacement. You can imagine that you've got a printer in a locker room somewhere, and you're switching up, you're printing this component or that, customized to the athlete. So I think it is going there. We have 50% of our athletes currently in customized helmets of some form, either 3D printed or machined. So I think from both accounts, the entire helmet, 3D printed, all that is going to become the norm very soon.
Okay, that's great to hear. Hey, so I realize I've been looking at the chat section and not the Q&A, and there's a whole list of questions from the audience. So unless Jim or Terry, you've got a strong opinion about that one question, I could go to these other questions, but go ahead if you are.
Yeah, I mean, I can just quickly say, I think it's a good question to ask of, like, can it be and should it be? Because I think, to me, the biggest thing right now is the additive can benefit is just getting it into the hands of the most amount of people. So figuring out which components you can pull from off the shelf and which components are coming from a printer, and ultimately driving to, like, the peak of accessibility is where I want to see additive kind of complementing other manufacturing techniques. We want people to use this stuff, and the more factors you put into that, I think there's certainly a vision to 3D print the entire concept of a product. But the idea really is we need people using it, and we need adoption to happen. So get it to a place where it is the most accessible is where I'd like to go.
Okay, awesome. Well, then let me go look at these questions. So the one at the top right now actually talks about embedded sensors, which I think I trampled on. But it has a second part of the question I think is interesting. It says, other reactions of the athletes while playing. So I guess this would go, well, to all of you. I mean, how are athletes reacting to this technology? How do they feel about it? Dr. Crandall, do you want to?
I think I just told you that, we've gone from virtually no one in customized to 50% within a, 3-year period. I think and there's other techniques. There's pressure techniques for customization that aren't using 3D printed. There's some traditional mold and machine techniques. But I think one of the advantages when you look at additive manufacturing is our top-rated helmet this year. We do an annual poster for education purposes, is a 3D printed helmet. I think if you look at energy management, comfort, mass, and it looks cool, right? I mean, if you're looking at the interior, I think it checks off all the boxes. So the reaction is very positive.
So the players like it. Yeah, that's fascinating. Terry, what about you? What about the hockey perspective? How are those players reacting to your helmet?
Oh, they all love it. It's not only they when they look at it, they see there's something going on. Like, not everyone is so aware of additive manufacturing and latticing. Like here, we around this table, we're all like super excited about all of this. But if you go in the street, like, people really know what's going on, right? So the interesting thing about these complex lattice geometries is it's intriguing, right? There's a sense of depth in these things, and when you take the object, when you take the product in your hands, you start experiencing something, right? You start to understand that what you have right now is different from what you had. So that first step, like, it's the perception. You perceive a lot of interest, a lot of value, and a lot of curiosity. Then you wear it. That's the second step. And when you wear it, the feeling of that lattice liner is something else. The comfort is great, and fit is probably the best fit you'll ever have. So right now, like, guys in the NHL, they really love it. People who try it, like people from around us, hockey players, different levels. Like, I'm not only talking about NHL players. Everyone who try it, like, they think it's an amazing fit. And then when you play with it, there's the breathability. So there's 3 levels of appreciation. Can I say that? 3 levels of sorry. There's 3 interesting levels So that's where it gets really, really interesting for the end user.
That's so cool. So just the user experience and how it sort of evolves from touching it and hearing about it, and then actually wearing it and then using it. That's fascinating. Jim, from the carbon perspective, you're probably dealing, I guess, with a lot of athletes. And I mean, how did they react to you?
Yeah, I mean, it's interesting because I think Thierry is exactly right. And like when they pick it up, they realize that it's an engineered structure and there's something more going on. So the first like technical look out of it just creates interest. And then you kind of fast forward to the early adoption, the guys that want to try it out. I remember a particular example with CCM where we gave it to a guy in the NHL and said, try this out there in practice, maybe use it in a couple games. Like it's safe, we know that. But just give us your feedback and then send it back to us and we'll study how it is after you wore it. And 2 weeks went by, he's like, I'm not sending it back. This thing is awesome. Like I'm having great games, like I'm playing really well. Like they get superstitious and they get hooked on it. Yeah. So those reactions have been really positive. And I think the other side of it too is I've worked with equipment managers who are trying to understand the technology a little bit more. And it's great to see them get into the conversation because they've got a different sense of care for the athlete. And oftentimes like they're gearheads in their own way and they want to understand how it works, but they always ask like, what data is there available to show us that this is a safer helmet? And that's why I love folks like Dr. Crandall who do this research to help kind of point to the safety systems that are available out there and the measures that come out of it. So I remember having a really good conversation with the equipment manager for the Packers. And we had this conversation and we looked at the poster and we showed them the printers, and it really just kind of all comes together in this really harmonizing conversation of you've got a highly technical process and a lot of great research that goes into it to give these players something that does elevate their safety to the degrees possible.
That's fascinating. So I hadn't even thought about the equipment managers. They're probably not worried about how good it looks, but the data, and the actual impact on safety. That's really cool.
They're worried about that, and they're worried about how they keep it clean.
Which it might be a challenge with really complex geometries, I guess. But so another question here, which is interesting, get your take on it. It's like, do you see these improvements industry-wide? And somebody's asking about Zenith and Shoot and Bauer and Warrior, all your competition is, yeah, well, I guess, or actually they're not your competition necessarily, Jim, but so I'll start with Thierry maybe. Is that?
Well, I don't know. Like, to be honest with you, I don't know what they're doing and I don't really care. But but to be honest with you, it's like injection molding. Yeah, at some point you have it's a technology. It's a thing to work with. They do whatever they want, but it's an interesting path, right? So I won't. Who am I to restrict or encourage? I don't know. Like I don't know, but there's a lot of potential. So
yeah, it seems to me it would be an inevitability that this is going to be widely adopted, but maybe you're at the vanguard of that, right? And
exactly, we like in my field there was no such things. I like to say that I approached like the first time I thought about it was with the midsole, right? It was the first version of the Adidas shoe where like we were like a kind of a design nerd, so I was looking at these things when they started. I think it was 2015 or 2016 at some point. So I was thinking that these things could be translated into something else, and so I was not at CCM at that time. I was working with one of the team of the NFL Challenge, Jeff. So
I didn't know that. Good.
You didn't know that?
Now I make the connection though. Now I put the name in a different context. Sorry. So,
and then when I first saw in person, I think it was, if I remember correctly, was Gurjeev Shada giving a keynote in some kind of a show, of a trade show. I just went to him, and at that time it was there was no such thing as a 3D printed helmet. So yeah, it's inevitable, but we were one of the first for sure.
Cool. Okay. Dr. Crandall, did you have any, I guess you know about the industry of the NFL, and we've been talking hockey so far.
Yeah, sure. And they all are obviously looking at 3D printing. I mean, imitation's the sincerest form of flattery, I guess. They're all coming along independently. I think, Shutt is working with several people. Zenith is collaborated with someone. Vices has used 3D printing in the past. So they are all doing similar to the Riddell and Carbon sort of plan there, and
okay,
we should see them in the near future.
So it's industry wide then, for sure. Here's a question that's bubbled up, and it talks about, this is all R&D at the professional level, but is there a timeline for this to filter down to the collegiate and high school and so forth for all the sports? You have any comments on that? And actually, Jeff, you might know, right? I would guess.
Well, and probably Carbon would answer this better than I would, but I know that some of the designs lacking customization, but just standard 3D printed and standard geometry, just based on mass and energy attenuation. You can even go with a standard geometry and improve upon performance with 3D printing. So Jim may have more details he wants to share. But
yeah, Jim, what do you think?
Yeah, I mean, it's definitely heading in that direction. So with CCM, production is underway. We've got the Back to Hockey launch coming up with CCM. I think it's in Q2 of next year. We've been talking about that pretty excitedly, that that helmet will be on shelves in retail stores in a non-custom form, but as Dr. Crandall's saying, in the same geometries, a little bit more conformal to a variety of head shapes. But it's making its way into the stores, and the timeline is now in many cases. I think you can go on Riddell's website right now and also buy their non-custom version of the SpeedFlex Diamond. Adidas has been there for a couple of years now. It was funny, during this conversation, I had another pair of Adidas shoes delivered by FedEx for my wife. So we're always kind of seeing, like, these things they are getting available, and they're getting to consumer price points, and we're really excited to get them in the hands of those people.
That's awesome. So yeah, so for Santa Claus needs to get me a CCM helmet, then it sounds like complex geometries, but not customized. But it seems to me, like I was saying, I guess, to Terry before we started the panel session, that my new iPhone 12 Pro has got this LiDAR. And so I'm scanning my kids' heads and I'm doing prints, and it's not terribly accurate, but it's getting there. So it seems like it's an inevitability that in 2-3 years, every helmet will be made for someone, right? And even at the lowest or the youngest level of sports. So that's fascinating. Let's see. So there's a lot of questions here, and I don't know how much time we have left. So I'm going to try we got like 10 minutes left. Okay, well, there's one about how do you ensure the final product meets safety standards? I guess, Dr. Crandall, that's your bread and butter right there. I mean, so clearly it's meeting those standards is what I understand.
A lot of testing.
Yeah. I think you saw when I gave an overview of what we do, and I think maybe mention a couple things with helmets. There's actually a certification body as well, NOXI, which does football helmet certification. I think one of the things that we're going to put out there very shortly is we've got tests that are based on all injuries occurring. But I think if you look at football, one of the things we know is it's position specific, that the lineman will have a different type of impact than a wide receiver, for example. So we're going to put over the next couple of years a whole new testing protocol in. Things like, helmet to ground test for players that would strike the ground like a quarterback. And so I think there's a certification, there's our tests, there's some consumer tests. So I'm sure these guys have a number of different targets to hit that are challenging to them, but there's no question that there's a thorough vetting process.
Okay. Let me go. There's one here that I think complements some of the questions we've done so far. we talk about the actual single impact and how that impacts the safety of the player, but somebody's asking about fatigue and failure life. So, if you got an Adidas shoe and you got a guy like me, 200 pounds, a little bit more than that, walking on it for, 2 years or a year, that's a lot of cycles. And so what about that long-term reliability? Maybe, I'll ask any of you to answer that one. Have you been looking at that? Is that a subject of a lot of studies and so forth? Maybe Jim? Yeah.
Yeah, I can start off there. So really all of the brands that we work with already have a bar for aging and accelerated aging to test the durability of their products. And we want to know just as much as they do how these materials hold up to those tests. So CCM, Riddell, they've all gone through the advanced aging cycles to really ensure that these products do perform at the length of time that they desire for them to perform for. I think it comes down to structure is a good part to gauge how long it's going to last. The more material there, I think the more durable it becomes, just generally speaking. But from a material standpoint, our materials are designed to last as long, or if not longer, than a polyurethane-based foam would. So we see a lot of lifespan built into these products, but it also comes down to that structure that is chosen for that product too, and that can vary based on what the application is.
Yeah, right. So the first thing that comes to mind to me is that a motorcycle helmet, I know, is considered like a one-time use.
Exactly.
You get in an accident, you throw it away. Whereas in the NFL, the helmet challenge, it was like, hey, we want these to last 10 years, which is a completely different, aging requirement. Terry, you seem to have an answer for this one. Have you? Yeah, on the fatigue or the life and reliability of these.
Yeah, it's foam is probably like not a great material for fatigue durability by itself. So replacing it, I won't say it's easy for durability, but I wouldn't say it's the biggest challenge. Like it's like what the composition of the resins are made of are usually better in durability than what we have in running shoes, for example. Like a typical EVA is not as durable as we could imagine. So yeah, I'm not a material engineer, but I used to run a lot, and I understand how it goes. So EVA is not as durable as we can imagine. So I guess all the manufacturers have their let's say their lines of their bottom line of durability, and even if it's printed parts, we won't get to a point that we do things that are not durable. That's for sure.
Hey, Eric, so I was just going to mention one thing. It's not just mechanical durability. We've seen a lot of chemical sensitivity of helmets, sunscreens, hair tonics. So those have been the challenges. I would say those have been more of the unexpected challenges with just helmets in general, with certain materials. So it's both the mechanical load as well as the chemical. Sweat in and of itself. Yeah.
That's just fascinating. Yeah, I would not have even considered that. But it's sweat. It certainly is a corrosive environment. There's a question here. How is CCM approaching improvement in the skate design? I bring that up because you just talked about running shoes, Terry, to avoid player foot and lower extremity. And I'm guessing that's a problem in hockey because that seems to be almost an unstable situation. But mechanical system in any case. Can you speak to that? The skates and additive manufacturing?
Well, it's not really. It's right now we're mostly working on helmets. It's mostly what we're looking at. It's probably where there's still a lot of work to be done. We focus our efforts on the helmet right now.
Right. It seems like the elastomers are really, they're changing padding, and so I'm guessing that the skates are not requiring a lot of elastomers, but stiffer materials, obviously. There's a question here about the cost point, and is that changing, evolving over time? Jim, I don't know. I mean, as the printing company, do you have insights into that, or?
Yeah, I mean, when we think about cost and making it accessible, one of the biggest things that we work with our brands to help them get to those accessible cost points are the design trade-offs. So I think we were talking earlier, might have been at the table, just about printer throughput and getting to those economies of scale. You can think about our printer is printing things kind of in you've got an X and Y platform that you can fit some parts onto, and then you've got the Z height that kind of drives up the print time. And the print time is going to be your biggest driver of cost. So oftentimes when we think about custom products, those are the ones that are using that full vertical height to get every single nuance of that person's head form kind of fit into the helmet. But when you think of more stock or retail-based products, you can change the orientation, you can change the throughput, and those allow for the same materials, the same structures to all exist, but you don't necessarily have to account for some of these other challenges that custom puts in. And just making those design changes to the way that you're producing have great benefits on the economic throughput of a printer. And that's what helps us get to these retail versus price points. Certainly a pro with multi-million-dollar contracts is not going to bat an eye at a helmet that's priced 2 or 3x at what you or I might be looking at in a shelf. So we've really focused on design optimization to get to cost that is kind of receptive to a customer.
That makes total sense. It's very interesting. Yeah. Well, there's a question here. Actually, this goes back to hockey. It's talking about goalies. And is there anything different that you're doing for goalie helmets that might help visual acuity? And that would be the NFL as well, right? I mean, you want to be able to get that peripheral vision. So Terry, let's start with you. I mean, is there anything specifically about helping the athlete in performance, really, and vision?
It's an interesting question. I didn't personally, or my team, we didn't tackle that, but I know I tackled that on a visor we did a few years ago, but it wasn't implying additive manufacturing. But it's for sure. Vision is an important part of the problem in sports, and improving it is a real opportunity for sure.
And Eric, I can add on that too a little bit too. I think one of the things that we've learned in our helmet development is the concept of like slop in the helmet. So how does that helmet move as you move your head very quickly in athletic environments? So I think as a kind of tangential benefit of using a custom fit product, that helmet stays centered on the head a little bit better and it's oriented better, so that as a receiver is running down the field and needs to make a quick turn, you don't have cage moving as much as it might on something that's more generic fit. So that kind of helps with the vision piece of it. But I think that sort of answers the question, but gives a little bit of perspective as to how this may be helping in that vision field.
Right. So just having that tight fit that's customized means that there's no time constant involved in moving your head. And then maybe even having the complex geometries means that you can remove material from specific areas that might obstruct view. And then, Dr. Crandall, I guess you certainly.
Yeah, I think if you look at sort of a design space and you're maximizing energy attenuation per design space, you can potentially reduce standoff distances with more efficient structures and materials. And then I think, Jim mentioned from a performance standpoint, but also from a safety standpoint. We're talking about helmets that are able to withstand impacts and keep the player safe. The best thing is if they can see an impact coming and avoid it. So actually field of view is a critical component to see an opposing athlete coming in. So it has been addressed by some manufacturers. I do think it's an opportunity, though, going forward, both from a performance and safety standpoint.
Interesting. Okay, so here's a question, and this one I want to kind of put my own spin on it, I think, but somebody talks about the production of hybrid additive manufactured parts. I'm not absolutely sure what that means, but possibly putting these parts and like overmolding several parts together, where you might have a part of different materials, so you get to not only modulate the geometry but the material properties, and they say similar to insert injection molding, which I think means where you injection mold a part and then you injection mold around that part, so you use two materials. What about multi-materials? I guess is that something that's interesting? Based on what Erica said, it's like you've kind of got the magic of geometry to make a material behave differently in different places, but maybe there's an advantage to have a really like a tougher material on one side and something that's more comfortable for the person on the other. Do you have any comments on that?
I can tell you, Eric, that one of the grant recipients actually had a liquid crystal elastomer that was very effective for energy management, but no way to hold on to it, no way to structure it, no way to incorporate it. So what they did is they used 3D manufacturing to provide sort of a scaffolding, pun intended there, structure, put additional energy components in with the liquid crystal elastomers and did sort of a hybrid design. So
wow, that's fascinating. Yeah, so basically the 3D printed structure is holding the shape, but then it's sort of infiltrated with another material that provides the performance.
Yeah, and passes the stresses. How it's not just hold the shape, but it's sort of stress management with an additive energy absorption component with the LCE. So
wow, that's really cool. That's so amazing. And then I guess that photopolymerization, the carbon process generally is a one material process, but I know that I've seen carbon parts where a bike grip has like a stiff section and then a soft, supple elastomer, and they were melded together while they were curing. I mean, do you have any comment on that, Jim? Are there opportunities in your perspective?
Yeah, I mean, I think you're right. Our print process only allows for one material in the printer at a time, but the secondary cure process does provide a path to bonding different materials chemically during the UV bake, the thermal bake. We have production parts that are using that, not necessarily in the athletic space, but when you think about our dental business and the dentures that we work with, those are teeth and gums printed separately that get thermally baked together to use those two different materials to create a really strong bond. But I think in the field of athletics, there really is untapped potential that we've been moving so quickly on the elastomeric side and filling the shells with what we can from a lattice standpoint that there's certainly work that needs to be done, an opportunity to figure out how do we incorporate other rigid materials or other silicone-based materials to create even better products that are complemented by a lattice in an elastomeric. So lots of opportunity there, but I can't say that anybody's cracked the question in athletics at this point.
Okay. Well, I realize now we've actually gone over time and there's like a networking section. So I'm surprised that I wasn't told that by Tara, the other coordinators. So I guess I need to just make sure I'm not like violating some rules here. Tara, is that, I'm guessing you hear me. I'm just going to talk all day about this stuff if you don't stop me.
You're totally fine. I noticed you went over too, and this is great. I didn't want to interrupt. It's a great discussion. Plus, we were a little bit late, so if you guys have the time, you can extend as long as you want. We can always keep going into networking. So,
okay.
I've got about 5 minutes. I have to jump. I've got another call to get onto, but happy to keep going for a couple more minutes. Yeah.
Okay. Well, then let's just make sure there isn't some really good questions that, let's see. So there's a materials development for athletic gear. I think we covered that. Industry-wide, we covered that. Okay. The question is the smallest lattice structure that can be designed and fabricated for miniature products and then to embed electronics into athletic gear. I don't know, maybe, yeah, I guess feature sizes are going down. So these lattices could be very intricate but yeah, Any comment on that, Jim?
Very generally, it depends type of answer, and it's going to depend on the material selection as well as the printer choice that we use to focus on like the resolution of that final product. But if you want the structure to exist, you have to account for some space to that exist, right? So typically when we've got lattice cell sizes, I think the smallest that we really are comfortable going down to from a cell size perspective is about 5 millimeters. And maybe some of my engineers would even kill me for saying that because we're getting really tiny in the cells. But the strut diameter is the piece that you have to watch out for. Is just how thin can you make those struts until the lattice is losing its integrity. But that's on the elastomeric side. On some of the rigid resins, you can certainly go much more tiny because the pieces are tougher. It just depends on the application and the material being used. But generally, I try not to advise customers to go smaller than a 5 millimeter lattice cell size.
Okay, interesting. Well, I know I've got to actually give an exam pretty soon, and this has been fascinating. I just can't wait to see the next steps for this whole industry to move forward. You guys have any last parting comments? Jim, you said you had to leave, so maybe if you had anything you wanted to finish with.
Look, I mean, I think it's been great to have these conversations, and I'm really so happy that people are finding ways to continue to have these conversations in a pandemic time. When we started the engagement with CCM, it was really a fun experience to get to go visit their office in Montreal, and they've got a locker room as a meeting room where all the equipment kind of surrounds you, and you actually feel like a hockey player again with all the equipment. That environment really kind of sparked the innovation and really got all the teams working together. So I'm just really thankful that organizations are putting together events like this so that we can have these conversations and get the conversation going again. So I think with that, I appreciate everything that's gone on today. I think the industry is heading in a really exciting direction. We can't wait to share more products, build new, really cool things with everybody. But it's a fun space, and sometimes I feel like I got the best job in the world getting to learn about what all these companies are working on and trying to accomplish with additive manufacturing. So, Eric, thank you very much for moderating. Jeff,
if you need to drop out, Jim, it was just a pleasure talking to you today, and thank you so much for the conversation.
Thank you. I appreciate it, guys.
Thanks, Jim.
Definitely. And then Dr. Crandall, Terry, do you guys have any last words you'd like to say?
I'd comment on the collaboration aspect. I think you just saw, an additive manufacturing company, and we've got, obviously with CCM, we've got an end manufacturer here. What I can tell you is when we look, we see this collaboration is even going to be broader. We see some chemical companies brought in. We see universities. I can tell you from the biomechanics side, the more revolutionary you go on design, then the specifications we're given are insufficient. If you come up with a design that fundamentally changes the performance and how it interacts in a collision or how it interacts with other helmets, then the information we've given you for design is no longer valid. So there needs to be a sort of continuum approach, and it really needs to be a full-scale collaboration. That's the thing. There's tremendous opportunities here, but you need to think of who are the partners all the way from beginning to end that you would bring in to really reap all the benefits. So that's my parting thought. It was great. I'm super excited. But I think, we need to think broadly.
Yeah. Interdisciplinary. Yeah, for sure. I think, and Terry, I think you agree with that too. We were talking about that before the panel. Any parting thoughts?
We discussed about interdisciplinarity. Dr. Crandall is right. This technology and the sports by itself is so complex. There's so many data. There's so many things going on. Having a lot of different perspective, a lot of different lenses, and combining these lenses will give us the right solutions. So for sure, it was a great collaboration with Carbon. It still is. We have a lot of collaborations with a lot of different peoples, and that drives innovation. This collaboration drives innovation. It's a culture we're establishing, this culture of innovation, and it for sure. It's a collaboration is a big aspect of it, and biomechanics is it's like the raw mat of this of these innovations. So yeah, it's a great thing we have these discussion. It's thanks for inviting me. I'm grateful about that. So thank you.
Definitely. Yeah, so I totally agree with everything you're saying. As an electrical engineer, I'm an outsider in this football helmet world, and I'm ready to like juice these helmets with all kinds of intelligence and computer vision and sensors. But so it was a pleasure talking to you, both of you, and the other panelists. I thought this was fascinating. Tara, I think I've got to go give an exam. So I've got terrified students right now that are waiting for me.
I hear you. Thank you guys so much. I really, really appreciate you guys doing this and having this conversation. I thought it was fantastic. So thank you guys so much. Really appreciate it. Yeah, I think, John, if you want to jump on and give a couple closing words, and we can break into networking. I get him up here. There.
Caught me off guard. I was.
I didn't mean to catch you off guard.
Oh, well, our closing remarks might be frozen.
Well, thank you guys regardless. So, there you go.
Am I here? Can you hear me?
Yeah, there you go.
Okay. Sorry, I don't know what was going on. Thank you, Tara, for saving me, and thanks to all of you. That was really interesting conversation. I think there's no shortage of opportunity in additive. We're all aware of that, but I think it's really cool. And we've been talking a lot about this here lately. The idea of, we've been talking about AM as becoming, industrialized. How does it get to the point where it's moving to production? Most commonly we're talking about that as it relates to things in, aerospace, automotive, energy, those kinds of sectors. But meanwhile, there's just so much opportunity within the space that you guys just walk through, and also this really cool intersection. And I think it's, what the NFL Challenge was all about, all these different disciplines coming together to really take advantage. I mean, if you think about it, it's where AM needs to be. It's utilizing the technology to its fullest extent. We're not just replacing a part. We're thinking of new and innovative ways to do things. So thank you all. Certainly appreciate all of your time. Today we're going to, I think, wrap here in a second and then go into, we have a social hour at the end of this where we still have networking available. So encourage all of you all to participate in that. We're going to, as I mentioned early on, we have another event in a couple of weeks called our mini TRX, which is, it's going to be more standard centric. It's a conversation we've been pushing for the last few years through the AMSC, or the Additive Manufacturing Standards Collaborative, looking to re-engage the community in that space, knowing if we're wanting to use the technology to make parts that matter, we all understand standards need to exist. We need to understand, as that manufacturing community and the supply chain grows and more people start taking advantage of this technology, we all want standards to exist so that we're leveraging them the right way. So whether it's for a helmet or for my automobile, we certainly want testing and standards to be in place. So thanks, Eric. Thanks all of you. Appreciate your time. Really, really exciting conversation. So with that, Andera, I think we're ready to wrap and go to networking.